against human and beat them in checkers, and having the wide public being able to do that actually, because you had other blocking steps in the way, for example, the lack of internet. Another thing that and this is a slide that I just copy-pasted from a Googler, he tries to show how well does Google does translation. And his Korean is putting here some text in Korean, and is using translation from, I think, from English to Korean or vice versa. And he's showing that it does phenomenal, it brings phenomenal results, compatible with experts translation. And he mentions that that now Google Translate is available in general availability since September 27, 2016. Now that may sound impressive, but to people who know machine learning, it was well known a few years before that the only way to achieve very high standard translation results was to use recurrent neural networks. So why did it take for the most advanced technological company in the world a few years to bring this very, very obvious solution that RNNs can do translation to production? So maybe when you're trying to search images for AI applications, you find a lot of slides, a lot of great ideas, but perhaps when you try to look for applying AI, it should more look like this, right? A lot of companies are like, the dreams are big, but the reality is kind of shady. And when I go to customers, and this is like a secret that I shouldn't be telling, and I have some customers that are doing very successful machine learning deployment to production. Sometimes they really rely on this single person that is a machine learning hero, superhero, and that is a person that does the research and the data analytics and the development. And this guy also kind of a girl, she kind of knows how to do the ops and to talk to the managers, and she really well understands the product. And I think like the number of companies that have really good machine learning applications running in production is kind of correlated to the number of people to the number of machine learning superheroes in the world. So, and this is obviously cannot continue. But you should be very relaxed about it, because if you think about software development, it was just the same, right? If you think about the 30s, you'd have to be Alan Turing in order to develop machine learning applications, software applications, right? In order to write code, you have to be as genius as Alan Turing. And then if you see like the I think 2018 movie Hidden Figures, you have to be a very technical person with a very good background in math in order to know how to operate in IBM and to write code. But then at the .com area, we started to see more higher level languages, programming languages that enabled more people to actually create software. And nowadays, you can actually create a website without writing a single word, a single line of code, right? So the abstraction of tools really helps us simplify the process of creating software. And for machine learning, you can think of TensorFlow as doing this process, right? If you started working in machine learning in 2012, you'd have to know a lot about the math and the derivatives and the backpropagation. But really, if you're using TensorFlow today, you don't really have to know the derivative of a sigmoid, right? You can just say you want to have a neural network with 5 layers and use the TensorFlow syntax in order to create your network. So TensorFlow is really part of the solution, but it kind of portrays the situation as if the ML code is like the bulk part of developing machine learning applications, right? You would talk about, when I'm talking about machine learning applications, you would talk about if I'm using convnets, or if I'm using recurrent networks, if I'm using dense networks, am I even using XGBoost, how many layers I'm going to have, how many filters I'm going to have. And it sounds like it's like the bulk part, but really you can write your machine learning code in just a few hours. And then when you want to bring it into production, it more looks like this, right? You have to worry about data verification and the serving infrastructure and like your data validation and pre-processing. and a lot of different, and a lot of big workloads that you have to do besides your machine learning code. So Kubeflow is an open source project that is supposed to help us overcome many of these tasks that are not solved by TensorFlow. The name implies that it's TensorFlow and Kubernetes together, but it's not only TensorFlow. Like TensorFlow is a representative of machine learning. It's actually a set of several very well-known libraries that are very well used in machine learning today for serving, for preprocessing, for writing models, for training models, for distributing the training. Just stringing them all together into one package that enables you to do all of your machine learning development in one place. So who's going to use Kubeflow? It's going to be used by data scientists, it's going to be used by the ML researchers, it's going to be used by the analysts, the developers, the DevOps people. Basically everyone who's involved in the development of machine learning pipelines is going to be able to use Kubeflow and leverage it to some extent. What is it? So it's a portable production grade machine learning on Kubernetes. It's currently in alpha, so don't expect that it will be perfect right now. It's an open source project, but the expectations for it is to be beta by the end of this year, and it's really progressing so fast. I've been given this talk, like it's I think my third time that I've given this talk, or fourth, like the 3 previous times were in Hebrew, so it's kind of different for me right now. But every time that I'm like rehearsing the slides, I make sure that the things I'm saying are really relevant, because everything is like changing super fast. So if you want to work on Kubeflow, you should really make sure that you're up to date with the latest version, and you're really taking advantage of all of the new features that are coming on like monthly basis or weekly basis. So why do we even need Kubeflow? So what's the idea? You can also think about you can also compare it to developing web services in the past. A lot of companies used to have their own web service code, right? And now with Lambda functions or cloud functions, you no longer need that, or you can like share a lot of these way to serve your logic. And what makes your company unique is not the way you serve it, but rather the logic itself. So in machine learning, it's kind of the same, right? You have your own model, you have your data. So what's makes your company unique is your data, your business implementation of the problem. But the way you serve the models, the way you train your models, is really something that most companies can just share between them. And this is what makes it very reasonable to make it an open source project. So key concept that we're going to have in Kubeflow. First of all, portability. We're going to have an ability to take our production system, and scale it and move it between clouds. Or if I'm starting to work on my MacBook and then I want to move to the cloud, I want to have the same experience. So once I deploy my Kubernetes anywhere and I deploy Kubeflow on this Kubernetes cluster, it's not going to make a difference to me if I'm running on AWS or on Google, or if I'm running on-prem. Another thing that is extremely important when you talk about machine learning is scalability. Not only in the serving, because once I have the model deployed, I can like go from 0 to millions of requests per minute, but also in training. So sometimes I want to train my model on a very small sample of data, but then when I see that I get good results, I want to train it in scale on like a lot of data. So scalability is extremely important, and I'll be able to achieve that by using Kubeflow. Composability. The people who actually develop machine learning applications, they know that they have like these parts of their code that can really be shared between different models that they're building or different projects that they've been working on, but they don't really always usually reuse their code. And you can think of maybe we can create some components that we can compose later in order to create these pipelines, and we don't have to we'll be able to reuse our code. Another key concept that we're going to have in Kubeflow is a full ML lifecycle. We're going to created this platform that is supporting us from the discovery of the data, from the pre-processing to the training and deployment of the model. And it's going to support GPUs and TPUs that are specifically used for, or very commonly used for machine learning. So how are you going to achieve that? So if you're running on, if you're running on Google, you might be using a lot of services that enable you to do machine learning, right? You can use the compute instances and the AI platform to do your training, and perhaps cloud GPUs to do training, or you're using BigQuery to do the pre-processing. So you'll still be able to use all of these services, but we're going to put a layer on top of that, and this layer is going to be Kubernetes. And we're going to have a cluster that is going to allocate the resources for us. So if you want a compute engine, for example, we're not going to reference the VM itself, but rather we're going to let Kubernetes allocate us this compute engine with a GPU. And on top of this Kubernetes, we're going to have a lot of pods that are actually very standard machine learning tools that we all know and love, like Jupyter Notebooks, or machine learning pipelines, or hyperparameter tuning, or TensorFlow. So Kubeflow is not really inventing anything, but rather combining very well-known tools into one singular seamless platform. So let me just go and show you my console and see what is this Kubeflow that I'm talking about. And I'm going to steal this gentleman's water. So when you enter Kubeflow, what you're going to see is like this new UI. It changes. It changed like I think 3 months ago. You can see here the link to the documentation. You can see here the pipelines. And I'm going to talk about what are pipelines, and I'm going to demonstrate how to work with them. You can see here that you can build network servers. So if I want to have a Jupyter notebook, I'm a data scientist, and this is something that we see in lots of companies. Notebook servers are not always used. Like you want to do some research, you want to do some testing on a new model, so you need a server ad hoc. So you can launch your own notebook server, for example. And just like next, please. And I'll launch it, and let's see what happens in the background. So if I go here to my console, I'll see that I have a Kubernetes cluster running, a GKE cluster running, and the workload that it's running is actually a lot of workloads that are related to machine learning. For example, here you will see the Jupyter web app that allows me to run Jupyter notebooks on my cluster. So I can allocate resources dynamically. So I don't have to have a machine up and running all the time. I can use the cluster to auto-scale, and when I need when one data scientist is working on a Jupyter notebook, then I can allocate this resource. And if 10 people want to work at the moment, then Kubernetes will automatically auto-scale and allocate resources. And you're going to see this under the node pools here that are currently have 3 nodes, but if I will try to launch many more servers, I could scale up very easily and seamlessly. And that is very natural to whoever works with Kubernetes.
Yeah. Quick question, does the notebook sync with the GitLab so that you can share code?
So it's basically, you don't feel the difference between running notebooks on Kubernetes and on VM, and you have the same integration that you have when running on VM. So yeah, you can set up your credentials on the server that you started and download your code from GitHub.
What about user authentication? Like user A has, let's say, first 3 notebooks, user B has another set, and is there a clear separation, or is it free for all?
Yeah, okay, it's a very good question, because it just changed it in the recent version, and I actually had an issue in like 2 versions ago about this that I opened in GitHub. The way it works right now is that on GKE you get, in Google Cloud you get authentication using your IAP. IAM. No, IAP. IAP. It's based on your IAP. And everyone who's connecting is creating his own namespace. So you can see here that when I created the cluster, I selected my namespace because I'm the only user. But you can connect to other people's namespaces and then create notebooks under these namespaces. So there is So virtually you can separate, but you cannot control. You cannot control. If you want to restrict, you'd have to wait for later versions. But it is a concern. There is a track for better user management. Maybe other questions?
Do you know what IAP is?
Yes.
Everyone?
It's
So
your
it's your Google
account.
credentials, right? So that
It's
you
your
can
Google
sign into service with your Google credentials. And a namespace, for those who aren't new to Kubernetes, is essentially a way that you can close off parts of a cluster with security parameters so that only certain people can have access to that.
Building on a previous question with integrations and companies using Colab, how does that work together?
Okay, so I think you're referring Colab is like the notebooks that you have for free, right?
Yeah.
So Colabs are kind of not part of, I think they're not part of Google Cloud. They're kind of more related to the docs or the slides.
Yeah.
There are some limitations in using Colab. For example, you don't know what is the resource that you're getting from Colab. It's not connected to your Google Cloud account. So it's more of like if you're trying to teach something and you want to share this notebook to your classroom and everybody can work on the same code. So that would work fine. But I think like if you think about production systems and you want to have your Colab connect to BigQuery, that would be kind of tricky to do, and you have to give credentials. So it would be more comfortable if you're talking about production grade machine learning to work on regular notebooks running on Kubeflow or AI platform rather than on Colabs.
But that is only if you are using your Kubeflow inside of Google Cloud, right? Because if your Kubeflow is completely dependent, I mean, it's not a problem. Right? You can have your own things running there.
Exactly. So the thing is, once your DevOps person is taking care of connecting Kubeflow to giving Kubeflow the right permissions, then it doesn't matter if it sits on-prem, and then you can give the cluster permission to access Google services. So in terms of the user experience that you're going to have, you're not going to feel anything different. You're still going to connect to this wonderful UI, and you're going to experience that like everything goes very seamlessly and fluidly. But the DevOps person is going to have like a difficult time setting up at the beginning. Okay. So let's talk about Kubeflow pipelines, and this is like my favorite part of Kubeflow. The idea is to have end-to-end orchestration of the machine learning pipeline. And I'm going to talk about what is end-to-end orchestration. I'm going to demonstrate a few pipelines. You want to have a very easy way of doing experiments, right? Because after you've written your pipeline that is made of data aggregation, data validation, some kind of pre-processing that you want to do, training and deploying, you may want to try doing this, running this pipeline with different parameters, like different networks or different hyperparameters, and see what results you get. So you want to have this ability to do easy experimentation. And I talked about composability. So I want the pipeline to be composed of different components that I can like put in together like a Lego, and like very simply build this pipeline out of these components that I'm making. So what's in the pipelines? So you're going to have a user interface. You're also going to have a way to schedule and run the pipelines. And you're going to have an SDK to run it. So let's take a look on the UI that I was talking about. And by the way, my notebook has started. It's a little slower than running notebooks on AI platform. These are a little bit faster, but it has its advantages and disadvantages that we can talk about later. And this is just the regular Jupyter notebook that we all know about. And you can also get, I think, the lab here. Right, so let's talk about the pipelines. What you see here is a bunch of pipelines that come with the default installations. They are just part of the open source Kubeflow. And what you can see here is the first pipeline that we're going to talk about. It's called flip coin, and the idea is to check if our coin is fair. So the thing is, the first step that we're going to do is we're going to write a code that simulates flipping of the coin, and then based on the results, we're going to generate random numbers. And based on the results of the random numbers that we generated, we're going to print some outputs. And well, the colors are not very well shown on the screen, but it has different colors here and here. And the idea of the pipeline is like this. What you can see here is that you start by accessing the first component of the pipeline, and then you're going to have a condition that is going to check the output of the first component, and then based on this condition, it's going to decide whether it's going to continue to run the next components. In order to do that, you would usually have to write YAML files, but nobody likes YAML files because they kind of like make you nauseous. So there is a nice way of doing that with the domain-specific language that the Kubeflow guys are developing. And let's see what are they doing. So for example, I'm writing here a Python class that is called random number operation, random number op, that is basically inheriting from container operation. And you can see here that my image is Alpine, and Alpine is just a Docker image that is used to run a bash command. And my bash command that I'm passing in as an argument is just a Python code that generates random numbers between low and high. So I have a container here that knows how to run Python code, and it goes here. So what's going to happen when I'm going to run this pipeline? If I'm going into this condition, then it will just run this container. So this is the idea behind Kubeflow. It's running containers, and it's chaining them and it knows how to chain them. So I'll continue to the next slide. This one. What I had here is showing you that I can also write containers that flip operation container, which creates the coin flipping, and the print container to just print the messages. And when I want to chain these containers, so basically it's going to look like this. I'm creating a pipeline, and I'm creating a function that runs the containers that I defined, like the object that I defined. So the first thing that I'm going to run is the flip coin container operation. So it's going to create a pod of this container, and then based on the results on the outputs of the flip, it's going to decide if it's heads, then it will run random number operation. So it will run a different this container between 0 and 9, or if it's tails, it's going to run random number operation between 10 and 19. So this is kind of a way of running tasks, and based on the results, deciding what to do next. So let's see how I run this. So this is the pipeline that I showed you before, and I'm creating a run. Let's call it V2. And I'm going to choose an experiment. I'm going to talk about what is an experiment. But the experiment here is coin flipping. So my experiment is kind of to see if my code is fair. And it's going to be a one-off, not going to make it a recurring one. And you can see while I go, let's wait. Then what it would do, it would start scheduling my pods one after the other and run my pipeline. So here we start by making the coin flipping, and you can see the logs here. So the log is tails, it already finished. And it finished also the other steps. It generated a random number, and eventually it printed what I asked it to print. Okay? So what does it have to do with machine learning? So you can think about it that what I created here is actually a way of making pipelines. And instead of now writing just Alpine code with a single line of the Python, I can actually create much more complicated pipelines using containers that do data aggregation and data validation and training. So I have this, for example, pipeline that is also coming with a default installation of Kubeflow that is working on the Chicago data set in order to predict whether a taxi ride is going to end up with a tip or not to the driver. So what we do here, if you can see, is that I'm starting by validating on the data, doing some pre-processing using data flow. So actually Kubeflow is launching a data flow work to do the pre-processing. This is kind of an interesting way because you can decide if you want to run your code on your cluster or you want to send it to an external service. Later it does training on the cluster, and later on it does prediction and shows me the metrics that I got. So let's see, I ran this pipeline before. So if I look at experiments, and experiments is just a way of organizing my runs, you can see that I have V1, V2, and V3. And you can see here that I ran them probably with different parameters, and this V1 was much better than V3, because here you can see the accuracy score of my run. And I can also see that this one failed. So I want to see why this one failed and this one succeeded. So I can select these and make a comparison. And you can see the hyperparameters that I ran my pipelines with. So V1 that succeeded ran with this. All of the parameters are just the same. Besides this one, V1 ran with this bucket, and V2 ran with bucket that does not exist, and that might result in an error. So that allows me to monitor not just my results of my pipelines, but also see why I got errors. And if I want to see why V3 was less good than V1, I can compare the hyperparameters and see that V3 ran for more steps. So perhaps I'm overfitting. So it's a nice way of experimenting with our pipelines and see different results. Right. So these are pipelines by Kubeflow. Very, very cool way of controlling your environment. I know that a lot of companies, well, they usually start with one person doing machine learning, right? And he has and he or she has their notebooks and they're running their experiments. And when they want to scale out, many times things get a little messy, right? You don't always keep track on where are all the notebooks that you were running, or which results you got for running the experiments with which parameters. So Kubeflow really helps you sort all of this together and organize your way of training machine learning pipelines. Some more cool features that you have integrated. So as I showed before, you get accuracy scores integrated within the pipelines. If you go here to the outputs of V3, you'll be able to see the ROC curve and the confusion metrics and TensorBoard and very cool things. It also integrates very well with TensorFlow Extended. And TensorFlow Extended has cool features that enables you to do data validation. So for example, you'd be able to see the distribution of your data, the distribution that your data ran on, and also model validation. So after you train, you'll be able to slice your data and your model and see which results you get for different slices of the data. And by that I mean, for example, I can choose this feature, which is the trip start hour, which is a feature that I created for training. And I can select one of these and see how the model performs on this slice of the data. So it really helps me understand better what my model is doing, and it's very important these days to companies when they want to make sure that their model is not like creating biases. So this was my talk, and I'd love to have some questions. Yeah. You. I know you.
Can you use pipelines to do DevOps stuff and not ML?
Definitely. You're just basically running. You're running containers. So containers can run running conflicting, and they can run deployment tasks. You can basically run anything.
In your talk, you mentioned that you can have pipelines running on either the cluster or Cloud Dataflow. Now, Cloud Dataflow has a very Java-centric, way of doing things, like you specify your do-within and all that stuff. How does one translate? I fail to see how there are payloads that can run. Pipelines that can run on Dataflow without any type of modifications. I can see it on the running on the Kubernetes cluster. That's fine. But I'm a little skeptical about having any pipeline running on Dataflow.
So
due to the programming language of it.
So the idea of Kubeflow is that each and every step of the pipeline is a container. And the container can run its own, can run on the Kubernetes cluster itself, but it can also just call use an API.
Oh, I see. So you're talking about an API call. Okay,
yeah.
I see.
So it's just,
okay, then that makes sense.
So just an API call.
Is it running behind the scene jobs for completions, or does it run? What does it run underneath? In Kubernetes, how is it translated to?
Yeah, so you have
Kubernetes.
so you have a list of pods that are running. Each and every one of these, one of the pods is called the pipelines, and the pipelines is responsible for scheduling other pods that are actually the code that you're running.
So there's no jobs, and that's
No, they're not jobs.
for
They're not jobs. First of all, you're running on top of Knative, but they're not jobs. They're regular containers running.
Oh, so it's Knative.
Okay.
And also another question: how does it work with ECR, where you have to get the credentials every 12 hours? Does it?
I'm not sure about that. I'm more.
Because there's a lot of other open source projects like that, like PolyXon and stuff like that, that failed to do this specific task.
And what
To retrieve the images from ECR, because the credentials are getting changed every 12 hours. Has anything about this that you know?
No. Not sure.
So let's say like a data pipeline process that's running in Spark, and you're processing like a billing rows or something. Does like that stage then, that billing row processing happen in like a single container? Can you distribute the containers? Like how does that make sense?
Okay, so there are some pods in Kubeflow that are supported natively. For example, distributed training. So if you have machine learning code and you want to run it distributed on the Kubernetes cluster that is actually the Kubeflow cluster, that would be supported. Data processing is not distributed in Kubeflow. So it's either you are bringing your own distribution method onto this cluster, or you're calling a different another service. And for example, you can launch a Dataproc job that does your preprocessing. And what you would do is that you would send, for example, you would tell Dataproc where to search for the data, do the preprocessing, and write the data to cloud storage. And then the next step would be to retrieve this data from cloud storage, and the containers will only pass references to the data between them. So you're not actually bringing the data in this step. The preprocessing, you're not bringing this the data onto the Kubernetes cluster.
That's a follow-up question. Like,
Sure.
So with, like, from an industry perspective, like Spark's been around for a while. Do you see a movement, like Spark can get complicated to run and manage and cost. Do you see that movement happening as people move to more Kubernetes, aside from services? Are you seeing like Spark jobs also start moving in this Kubeflow area where you're calling APIs and stuff to do processing and heavy lifting on other systems?
So I know that there, my field is not really big data, so I do know that Spark is also already integrated with Kubernetes. I'm not sure that, but I'm sure that you'd have to replace, you'd have to replace Spark, but rather, the idea I think it would be wrapping things. So you don't really care today. I've ran some really heavy loads Spark jobs on Dataproc, and it's really easy to do actually, because Dataproc really well manages your Spark cluster. So I think that the way I would work is just using this abstraction called a Dataproc and not really caring about what's going on in the background. But sometimes you do know that like tuning your Spark cluster can like be very tricky. So there are platforms that are, there are tools that are replacing Spark and moving towards Kubernetes, but it's not really my field of expertise. I'm more of the machine learning and less of the big data. Yeah. You've already answered that.
Thank you. I think a great presentation about machine learning. My question is, your earlier slide, you had 1947, there's checkers, which was 8 by 8 square, which is like 64 squares, where two players are playing on a kind of closed boundary. We don't have that kind of boundary anymore because we are global now. So actually and then I think later on, IBM came out with a machine which was computing chess game between Kasparov, which is a world champion in thinking, and also all the chess openings, middle game openings. I think today I heard that we had Mr. Pichai came with a computing machine which is using qubits. The qubits are basically a concept of new ways of looking, because if you're doing machine learning, you're dealing with a lot of data. The data becomes very big, and I think the computation, there are delays in terms of, it doesn't have the power to, like how to rotate the cancer cell in biology, or cosmic events, which are much bigger in data. Data is very big. So I think giving this concept of transition from modern computing machines, the way we are looking at this today, the next one, which is the machine which has been announced today by Google.
So just point out the question itself. My perspective on
Machine learning.
But more specific on the impact of computers on machine learning.
Yeah, I think how do we go machine learning from binary computing to two-dimensional qubits computing?
You are talking about quantum computing, right?
Yes.
Yeah.
So I think like naturally it's going to affect the same way it's going to affect every other part of every other computer software that you're running. You'll be able to perform more computations per unit of time, then you're going to have better performance, especially in machine learning when you're running a lot of operations to accomplish your task. It's just going to boost your ability. I'm not sure it's like specifically impacting machine learning. But
Well,
yeah.
I think there are two sides to it. One is like a computing part, because just like the way Renaissance started was we looked with 2 eyes, where we were looking all the paintings before 500 years ago, everything was in a flat screen. And I think this was Renaissance time when we saw 3 dimension. We were looking at 2 eyes. So I think what my concept is, today we are talking about machine learning, where we have a lot of data where machine is becoming much powerful than human mind, because it can, I can't remember my brother's name, because I've got 8 brothers, but the machine can remember all the guys who are here. So actually, my question is basically the creative part of the brain, which is the other side of the brain, which is like that's where the machine learning comes in, because actually the other part of the brain, it sees all the data and it's a creative move. Should I move D4 or D5 or queen to this place or that place? That's a creative field. I think this is where the
So you're saying that will induce a more sophisticated way of it would change the theory behind machine learning by simply being able to do some things in parallel. Like,
right, something parallel, yeah.
Well, I have to say that I failed my quantum physics twice.
Well, because you're still in the binary mind can't think of the qubit.
So I guess that will have some implications, but
Well, anyway, this is-
I'm too humble to tell you how it's going to quantum physics, quantum computation is going to affect machine learning in the future. There's a lot of good talks about it, but
What's a great presentation? For today's sake, it's very good. Thank you.
yeah, sure.
So yeah, I wanted to ask, like, before you showed the DSL, and how are we supposed to keep track of the DSL code? Because I saw that in Kubeflow you have the pipelines there in YAML format, right? And I guess that acts as like source control, or are we supposed to have that separate?
Oh, that's really good. That's a wonderful question. So there are 2 ways, for you to actually handle your code versioning. The first one is your code itself. So you're going to use GitHub. So you have the code that does the model processing and the machine learning. You're going to keep it in GitHub.
In this example, would be the flip coin, for example.
Beg your pardon?
In this example, it would be the random that line of
Yeah, exactly.
code, right?
This line of code, I would keep it in. Well, this one is a very, very simple pipeline that I'm running. It's running an Alpine image. But instead, I could save the code in GitHub and then containerize it and put it in a container repository like GCR. So instead of here building bringing the Alpine image, I'll bring my container from GCR and run it. And the arguments here would not be the code, but rather hyperparameters that are going to input to my container. So 2 ways to handle your code is one is GitHub, and the other would be to containerize and upload it to your cloud repository.
And the pipeline itself, should that be meta as well?
So this is when you want to upload, Kubeflow also has an internal way of internal database for your pipelines. So all of your pipelines in the database are presented here. All the pipelines that you're uploading are here, and they're stored in a database. It's kind of tricky there is no support currently for versioning of pipelines. So yeah, you would kind of I would use GitHub to keep versions of my pipelines. So the components, I would say, would be saved in GCR. The code would be in GitHub, and my runs of running the pipelines and my measurements are going to be under the experience stored internally on the cluster. It has a MySQL background running in the background, storing the results of it.
Last question. So, and if you have the requirement of having to work with a known and not moving set of data. So if your data set has to be known, because then it has to be audited or something.
What do you mean by known?
Like, say I'm running a bunch of different tests or algorithm or experiments, I guess, and even changing like different pipelines. But I have a single data set that I have to work with as an input.
Yeah.
How will you go about like tracking that data set?
I would start by actually replying to the opposite question. Sometimes you have a fixed pipeline and you're changing the data. For example, over different periods of time, you want to retrain your data on different periods and just substituting the data set. So you can put in one of the parameters to the pipeline could be a reference to the data set. If you want to use the same data set, then first of all, it's kind of easy. You can like tell it always to go to the same location where it's stored and bring it in. But you also have, and this is kind of new in version 0.6, you can bring your data as something that is compatible with a container. You can bring it as an entity under your Kubernetes cluster, and you'll get a volume. It will be stored on your volume, and you can connect this volume to different pipelines. So what's the name? Persistent volume. Yeah. Thank you.
How do you, can you go a little bit over the typical workflows from using Jupyter notebooks for data scientists to then jumping to using the pipelines? I mean, what's typical flow? For example, in Jupyter pipelines, I'm guessing, I'm not a data scientist, you do some experimentation in terms of, let's say you're doing some feature engineering, you decide on certain features, how do you propagate them now to Kubeflow, to larger data set and so forth?
Okay, so this would be the most painful point, because notebooks are really fun to work with. Do we all know how notebooks look like? So the idea is that it's fun. Just use the one I launched. So what I'm doing here is I'm launching a notebook, and this could be, and each and every line here is just running Python. And it's really fun to work with it because you see the outputs on the UI. So if I'm like building a data set and I want to make a visualization, I can like see the results and just under my code, and it's really comfortable to work with. So for the experimentation part, where I don't know what's going to be the model, I just want to see the data, want to try new things, I would work on the Jupyter. Later, when I kind of have a sense of what I'm doing and I kind of know where the data is coming from and what code do I need to bring on and what's the training that I want to perform, I'm going to kind of sort it all into a GitHub repository. And then I'm going to containerize my code. I try to break it down to specific containers that do very limited work, and then compose it as a pipeline and run the pipelines. So pipeline is kind of after you kind of know where you get the data and what's your machine learning code after you don't change the code.
I see. And is there any tooling that would allow you, for example, let's say that you came up to some final transforms for your features, to, for example, push that into a container? Like, so what's happening is, an organization, I mean, we have a data science team that's less technical, so some of these translations we're trying to automate as much as possible, jumping from Jupyter notebooks to the pipelines.
So actually, yes, this is the approach Netflix is taking. They've written a wonderful blog post, I think, about it 2 years ago. And there is a library that enables you to run notebooks as part of your pipeline. And it's supported by Kubeflow. I think Lack from Google also demonstrated. Very, it's called Paper Mill. This. Maybe it's not. This one. 2 chaos on for lack.
Just one.
No, I know, but it's not funny. So there is a. Oh yeah, this is one. This is the first one. So it's a way, and this is like from Google. So he actually has a very good blog post on how to schedule notebooks. So you're actually writing the notebooks. You have to have. You're basically adding input parameters and output parameters for the notebook, and then you could just schedule them using Papermill and build a pipeline of notebooks.
This is only part of the solution, because the idea here is that you have different team members who are specializing in different areas. So usually when we start to work, hi, my name is Yoram, I'm from DoiT. When we'll start to work, Gad will start to work on a problem. He's the machine learning expert, he's the data scientist expert, and he will start to play with the Jupyter notebook. At some point, he will start to better understand how he needs to massage the data. And then he will come to me or to somebody who knows how to code, and will ask who really knows how to code. And this guy will write the crunching, the pre-processing the data. While Gad will write in his notebook the model, how to create the model, what are the inputs, what are the outputs, what he wants to do with the model. But the idea is that you will have different teams. Each one of them will be able to build his container. You will know exactly what are the inputs, what are the outputs, and the brain will be written sometimes by different teams. And this way you will have the best teams working on exactly what they know how to do, and you will be able to move faster because you have the APIs, you have the graph, you have the DAGs that you define, and you are not dependent on the other team to provide you with the code right now, because you need to know what is going to run and how it's going to run. And you don't care if it's running on Kubeflow or on Dataflow or on Spark, you don't care about it. So you have a block that's supposed to run, and that's it. So this is
And I'm sure you can
To some extent.
Sorry about that. I think we're about out of time. We will be hanging around if you guys want to grab another drink and continue the conversation, please do. But above all, thank you for making time today. It was great to meet you all, and we hope to talk to you soon.